All right, guys, today we're going to go ahead and talk about area of a circle and a sector. So to determine the area of a circle, you take the radius squared times pi, as we see right here. Now, in the last video that we talked about, when we dealt with circumference, it didn't matter if I had radius or diameter. However, with my area formula, I have to have radius. And we're going to ignore these directions. We're going to leave everything in terms of pi. So when it gives me the diameter, I'm going to have to cut that in half to get the radius. So in number 1, my radius is 11. So I have 11 squared times pi, and 11 squared is 121. So my answer is 121 pi. Number 2, I'm given the radius is 8.4, so I have 8.4 squared times pi. And 8.4 squared gives me 70.56. Number 3, I have my radius is 13 squared. I'm sorry, it's just 13, so I square that and I take it times pi. And 13 squared is 169. I always get that one and 14 backwards because the numbers switch spots. That one I'm still working on. So 169 pi. And then number 4, because I don't want to run into my video. Again, I'm given the diameter, so I have to cut that in half. Oh my God, dropped them. So half of 14.8 is 7.4. So I'm going to take 7.4 squared times 5, which gives me 54.76 pi. Next, we're going to talk about a sector. A sector is an area of a circle that is, it's created by the arc, and 2 radii. So if we look here, we have this sector XOY. And just like when I said that the arc length is a piece of the circumference because part of the length all the way around, the area of a sector is a piece of the area since I'm having a little small chunk of that. To determine the area of a sector, I take the degree of the arc over 360 times my pi formula. So it's very similar to the arc length formula. The difference is I'm multiplying it by the pi formula versus the area formula versus the circumference formula. All right, number 1. We have the area of sector ZOM, and it's asking me to leave my answer in terms of pi, and we're going to go ahead and do that. So I'm going to take the arc degree of ZM. Well, if the central angle of ZOM is 72, that arc length is also 72. I'm going to take that times the radius squared, and I see I'm given the radius, so I don't have to cut anything in half, times pi. So I'm going to go ahead and put the majority of this in my calculator to see if it gives me a solid answer or to see if I get out a fraction. And I'd know my answer would be in fractional form if I got a decimal. 72 divided by 360 times 20 squared. And the way I'm going to enter this in the calculator is I'm going to put parentheses around my fraction, like so. And I get out 80. So my final answer is 80 pi. Find the area of sector ACB. Leave your answer in terms of pi. So ACB is the following chunk. I see that arc AB is 100 degrees since the central angle of ACB is 100 degrees. So I have 100 divided by 360 times, let's see, oh, yep, I'm given the radius. Radius is 6 times pi. And again, I'm going to put that fraction in my calculator with parentheses. And my final answer is 10 pi. Number 3, a circle has a diameter of 20 centimeters. What is the area of the sector bounded by a 208 major arc? Round your answer to the nearest tenth. We're going to go ahead and leave this in terms of pi again. So the biggest kicker of this problem is most people just pull out the numbers and don't read the fact that it's given you the diameter. So because we're given the diameter, we have to cut that in half before we start this problem. So my radius here is actually 10. So I have 208 over 360 times 10 squared pi. And if you notice, I end up getting a decimal. So what I'm going to do is I'm going to turn this answer from a decimal into a fraction because we want to keep things nice and even. So I'm going to hit the math button. It's going to show me this screen. I want my last answer to be in fractions, so I'm going to hit enter, and then it's asking last answer fraction. Yes, I'm going to hit enter again. So I have 520 pi over 9. So let's go ahead, yep, good to go. Let's go ahead and get out our handy dandy formula books so we can put those in. So the top part and the bottom part. Again, I just picked one of the problems and I worked it out. If you don't want to use this problem, you can use any of the 3 problems that we went through.